You know how we're always looking for those breakthroughs that make you rethink everything.
Oh, absolutely.
Well, today we're diving into a news report about a potentially revolutionary coin-sized nuclear battery. It's from a Chinese company called Betavolt.
Right. Betavolt.
And, well, imagine a world free from charging cables that is, could this actually be it?
That's the big question, isn't it?
So our mission today is to understand, how this technology works, what it could really mean, and, well, what questions are still kind of hanging in the air.
Exactly. And this isn't just some minor upgrade, The buzz around this report is from SidebySide. It suggests a real game changer.
A game changer, huh?
Yeah. We're talking about a battery that could potentially power devices for, get this, half a century.
Yeah.
No recharging needed.
50 years, wow.
Yeah. So for you, our listener, looking to quickly grasp the essentials, this is definitely packed with those aha moments.
Okay, let's get into the core of it then. This battery is called the BV100.
BV100, got it.
Developed by Betavolt in Beijing. And it's tiny, like coin-sized, about 15 by 15 by 5 millimeters.
Really small.
And it puts out 3 volts. But the power source is what's truly fascinating here.
It really is. What's fascinating is it uses the radioactive decay of nickel-63. That's ONI, a beta-emitting isotope.
Beta-emitting. Okay, so what does that mean exactly?
Well, beta decay just means the nickel-63 atoms release these high-energy electrons as they transform. Right. And this flow of electrons, that's what we harness as electricity.
Oh, okay.
And the beauty of using nickel-63 is its decay rate. It's predictable and relatively slow. Very slow, actually.
Unlike chemical batteries.
Exactly. Unlike the chemical reactions in traditional batteries that just degrade over time, this nuclear decay offers a really consistent and exceptionally long-term energy source.
And the safety aspect. Obviously a huge question with anything labeled nuclear. The report highlights this pretty strongly. It does. No volatile chemicals, operates at room temperature, apparently can't explode or catch fire.
Which is crucial.
And supposedly emits no harmful radiation externally.
That sounds pretty significant.
It is significant. The key to the safety really lies in that controlled decay process and the robust casing. It's designed to contain all the emitted particles.
So nothing gets out.
Right. Ensuring no harmful radiation escapes. Plus, the fact that the nickel-63 eventually decays into non-radioactive copper.
Well, that addresses some immediate environmental concerns, right?
Yeah, that deals with the end-of-life question, doesn't it? Okay, so let's nail down the key specs again for everyone listening.
Good idea.
Coin-sized. Currently putting out 100 microwatts, but they're aiming for 1 watt by 2025.
That's quite a jump.
And a lifespan exceeding 50 years. 50, I mean, just think about the implications of that. And this is where it gets really interesting. Where could something like this actually be used?
Well, this raises an important question about the potential impact across so many sectors. Medical devices are a prime example.
Like pacemakers.
Exactly. Imagine pacemakers or neurostimulators that never need battery replacement surgery. That eliminates significant surgical risks and just massively improves patient lives.
That's absolutely incredible. And then you think about consumer electronics.
Oh, yes.
Smartphones, drones, the whole massive network of IoT sensors we're building. The constant need to plug things in could genuinely become a thing of the past.
It really could. And beyond our personal gadgets, think about aerospace and defense. Long-term power for satellites, deep space probes, it becomes much more viable.
Makes sense.
And for AI and robotics, machines operating in remote or dangerous environments, a 50-year power source is a true game changer for autonomy.
The possibilities really do seem almost endless. The report even quotes an energy scientist.
Ah, yes, that's soft.
That calls this the holy grail of energy storage, compact, long-lasting, and safe.
Strong words.
Very strong. And they also emphasize the potential to eliminate disposable batteries and drastically cut down on e-waste. That point about e-waste, that's huge. Could you maybe elaborate on the scale of that problem this might address?
Yeah, absolutely. If we connect this to the bigger picture, the sheer volume of disposable batteries produced and then discarded globally is, staggering.
Yeah.
Billions every year.
Staggering, right.
So this technology, if it could be widely adopted, could significantly curb that waste stream. It would reduce the environmental burden associated with, mining the materials, manufacturing, and then disposal.
So what's the realistic outlook here? When might we actually see this kind of tech in action? Is 2025 feasible?
Well, the report does indicate Betavolt is aiming for mass production by 2025. That's ambitious, especially reaching that 1 watt goal.
Okay.
But the prospect of these nuclear batteries powering, maybe not our phones immediately, but perhaps specialized devices within the next decade.
Mm-hmm.
It seems increasingly real.
So, to kind of wrap this up, we're potentially looking at a major shift in how we power our world. This tiny, apparently safe nuclear battery could offer decades of continuous power.
Precisely. However, it is important we acknowledge the remaining questions. The report itself does mention potential challenges. Cost is one.
Always a factor.
And of course, public perception. How will people react to having nuclear tech in their pockets or homes? That's a big hurdle.
Absolutely. Trust and acceptance are key. And, well, that leads us perfectly to a final thought for you, our listener, and it comes straight from the article. Will this be the end of the charging cable era?
Provocative.
It really is. It's a fascinating question to consider. What would a world without that constant need to charge actually look like for you, for the future of technology? Something to think about. Thanks for exploring this deep dive with us.